Hi, welcome to my presentation. My name is William Lee. I am the course inventor and training instructor of Manufacturing Insight Skill. To begin with, I would like to explain what is the difference between hard skill and soft skill, and also what is technical and non-technical course. The general perception of soft skill program refers to personal quality developing program, while hard skill program means job skill training course. According to surveys, most of the soft skill training are inclined towards providing management, finance, IT, personality development, strategic planning, and marketing skill. Such training limits the scope of capability of trainees as they are mostly trained in managing people, things, or process. This training do not teach them to become skilled in creating, designing, improving, manufacturing, and troubleshooting products and technology with the most effective manner. On the other side, technical training courses have not received similar popularity as compared with non-technical courses. In fact, there is a void in our present training system, as it shows very few technical courses and technical trainers available in the training market. In addition, the response from local industry and participants on technical training courses is poor. More precisely, technical skills can be categorized into technical hard skill and technical soft skill. Technical hard skill refer to hands-on job skill, while technical soft skill refer to the in-depth technical study which teach learners the ability to apply science to reason a technical problem in different production scenarios and learn how to suggest possible technical solutions to solve the problem. Normally, technical hard skill involve the use of hardware, machinery, or tools which can enable the production of products, whereas technical soft skill teach the science and insight on how to make a good part which can enhance the performance of a manufactured product. Technical soft skill are referred to applying engineering theory, which is a missing link study in technical learning. This is to say, a technical employee who knows how to operate a machine is not good enough, but he must know how to produce a defect-free product. If he has this extra skill, he should be paid more than the ordinary technical staff. It is therefore recommended for technical staff to acquire useful technical soft skill to complement their shop floor practice. Most technologists and technicians consider knowing other manufacturing variables beyond the scope of responsibilities are not essential. The truth is, it is crucial for them to learn the inside of manufacturing details, as ignoring the details will jeopardize the overall product quality and productivity. According to John Wooden, who was a very successful and famous head coach of the basketball team at University of California, did say, "It is the little details that are vital. Little things make big things happen." Manufacturing should be regarded as a science but not a magic. A solid understanding in theory will introduce science and the engineering procedure to the manufacturing process by removing the uncertainties and give a consistent and repeatable result. Scientific manufacturing requires scientific workers. Technical soft skill based on scientific and logical reasoning will be useful to complement the hard skill practice and to train and develop scientific workers. What's the difference between traditional workers and scientific workers? Traditional workers do not document process often. They make adjustments based on their learned behavior, and they do not verify the effectiveness of each change they have been made. Whereas scientific workers study history of a documented process, they make adjustments based on fact and data, and they verify and document the result of each change that have been made. Let me show you some examples that I have witnessed when I'm doing troubleshooting service for my clients during my time as a service engineer in the 90s. Here, the tool makers struggle to produce quality tools despite having invested a multi-million CNC machine. The premature tool failures was due to poor heat treatment on the punch after the machining work. Remember, machining can only produce the shape of the tool, which looks like a punch, but heat treatment will give the finer touch and produce the desired tooling properties so that the punch can perform the job without premature cracking. Proper heat treatment is a missing link study here. In the second case, a car owner complained hearing noise from a new gearbox after running just 300 plus kilometers. Subsequently, the car manufacturer has announced a second recall exercise to replace the faulty gearbox. This has annoyed many customers due to inconvenient costs for the need to return the car for repair. The recall exercise also jeopardized the company image. The problem recurs constantly as the vendors have failed to study and correct the failure causes. I need to stress that quality control may pinpoint the defects, but the problem still need to go back to the basic to solve it forever. Technical soft skill know-how is used to reason a failure, suggest solution to remove the problem. The cause of the failure can be due to materials defect, poor contour hardening pattern on the gear T, which need to be studied and confirmed. In this case, the initial joint line in the molded car door panel was solved by enlarging the sprue size of the mold, but at the same time resulting in a nozzle drooling problem. When the molder tried to decrease the melt heat to fix the nozzle leaking problem, another problem happened when the part running short at the far corners. The fact is, a good product design cannot warrant a defect-free production without the support from a good mold design and proper molding method. The study of all manufacturing variables is important to solve manufacturing issues. For case number 4, the edge cracking tends to recur on the foam door panels. The metal stamper claims he has enlarged the die radius and provided a good polish finish on the die surface, but still cannot solve the problem. Eventually, this has forced the metal stamper to use a larger blank to form a panel so that the cracked edge can be trimmed off by a secondary operation. This has resulted in a higher material and production cost. Scientific workers will tell you that material has its strength and limit. Trouble-free manufacturing requires a complete understanding of material behavior, in this case the material formability, process parameters, tooling design, machine capability, and failure analysis. In this example, a shop floor technician resists to perform die preheating before running the aluminum die casting process. This has caused the expensive die casting die crack sooner than anticipated. Although the shop manager insists they have a set of guidelines on die preheating and die spray, but investigation revealed that the floor operators either never or abuse the guidelines without the manager notice. Please take note that floor workers who are running the actual production need to be trained and make known of their rules and acts on part quality and productivity. Here, a plastic injection molder has conducted a design of experiment to optimize the strength of a weld line on the molded part. The DOE result indicate a higher melt temperature and hole pressure, but cavity fill must be slow. Why slow? This has confused the molder. Sometimes running a DOE without considering the processing knowledge may give nonsensical result. Technical soft skill learning on process knowledge will train workers to use common sense based on science. In this case, the machinist cannot figure out why the machine bar become out of spec after turning and boring process. The problem here has something to do with the internal stress that was locked inside the steel before the machining process. Study of the prior history of a manufactured product is crucial to prevent unnecessary failure during and after the subsequent process. From the examples given, we can witness how these issues link to design problems, inappropriate material selection, poor machine understanding, inferior mold tools performance, and incorrect processing control. Each of these factors affected employers, customers, and suppliers' product quality and also their business profitability. During my employment time, I quickly realized the importance of equipping manufacturing variable knowledge in order to troubleshoot technical problems in an effective manner. I call this 5M study, referring to the study of manufacturable design, material, machine, mold tools, and method of processing. When facing with production problems, there are two ways to solve it. One is to fix it temporarily, while the other is to solve it forever. In reality, owing to time constraint, technical people are forced to fix the problem as soon as possible in order to meet the deadline and to satisfy customer requests. Such approach would never prevent the same problem occurs again, as the root cause of the problem never identified. And this is the reason why most shop floor workers are busy in their routine work to entertain reject, rework, and to replace the defective parts. a typical 3R working culture. To solve the problem forever, we need an advanced 3R to replace the traditional 3R. The new 3R requires us to conduct research on all manufacturing variables, the 5M, to review the procedures, and to re-engineer the process in order to solve it forever. Under this new 3R, technical employees are requested to troubleshoot the problem. First, patiently. There is no shortcut. Follow procedures to carry out the detailed investigation. Second, objectively. Analyze carefully with the collected facts and data. And third, logically. Use common sense with the scientific reasoning. Obviously, this approach required the new generation workers, we call it scientific workers, to take extra time and effort to accomplish the mission. The fact is, visionary company relies on the competent workforce with a sound knowledge on 5M to solve manufacturing quality and productivity issues. We need to develop and train our workers to become valuable resource in order to troubleshoot the manufacturing problems in an effective and scientific manner. 5M learning is a multidisciplinary study. This is a long-lasting industry knowledge that can develop and train scientific workers. Dr. William F. Deming, the American engineer who taught the Japanese about quality after World War II, say, training is important to achieve consistency for reducing variation. Training builds a foundation of common knowledge. Training allows workers to understand their roles in the big pictures. Deming always encourages staff to learn from one another and provide a culture and environment for effective teamwork. So how do we train our workers? How do workers learn? Statistic review, most of our learning takes place on the job or from our seniors. The formal process is without guidance. The worker receives the order from the superior and starts to work out the request. It is hardly focusing owing to busy working schedule for the employees to devote time to true learning. While the latter thought it is with some helps from the senior, but still it is not effective due to the complex human factors such as is the senior willing to train, know how to train, capable to train, and available to train. Off-the-job training is a more focus. We ought to know training is a profession. For effective training, we need professional trainer to develop a structure and systematic course syllabus. A dedicated trainer must be qualified to train, know how to train, and willing to train. Technical training is particularly important for a company to achieve sustainable growth and for countries gearing for industrialized status in the near future. Without proper training, your employees do not understand the materials, process, or the equipment around them. A company will be in a better position to succeed if the entire workforce is trained to perform their job effectively. In 2009, I was assigned by the Human Resource Ministry to train a group of unemployed graduates from different local universities with different engineering backgrounds. I was attracted by the comment from one of the participants upon completion of my training for him. The trainee seems impressed with my teaching and has requested me to try to make it a compulsory program for undergraduate study. That was the day I started to develop this manufacturing insight skill program for the benefit of the trainee, the industry, and the nation. Since then, I have been collecting all the jigsaw pieces from my previous experience to develop a comprehensive and systematic technical training module called MIS. MIS means Manufacturing Insight Skills. MIS offers a missing-link study in manufacturing improvement to provide our technical workforce an important working knowledge and higher-order thinking skills. Versatile employees with a solid applied engineering theory are able to explain with logical reasoning on a manufacturing issue rather than depending on guesswork. Technical personnel armed with a 5M knowledge will enhance their employability skill with a better career advancement and certainly deserve a higher pay. MIS has 7 learning modules according to the manufacturing industry subsegments such as precision engineering, injection molding, metal stamping, semiconductor assembly, die casting, forging technology, and materials engineering. To date, I have developed more than 150 topics under various modules with a 4 hours learning time per topic. These topics are developed based on real cases experienced by technical employees who are desperately finding ways to solve technical problems but have no time to conduct a detailed study on a specific engineering subject. As it goes, there are no limit for the number of MIS topics. Newer topics based on 5M concept can be added to the list to meet the industry and the workers' need. MIS can be used to promote industry-led TVET study. It can also create awareness and interest in STEM learning as it teaches topics related to science, technology, engineering, and mathematics. A strong understanding of a 5M knowledge will help technologies and technicians to develop, evaluate, compile, and interpret manufacturing data, which will be crucial in facing the demands of Industry Revolution 4.0. The unique learning modules of MIS offer industry-led technical soft skill training topics that are current and relevant to both the education and manufacturing industries. The target audience from academic institutes includes TVET students, university undergraduate, unemployed graduate, and teaching staff. Assisting workers such as managers, engineers, supervisors, and technicians from the various engineering departments can also benefit from MIS training. Here are the benefits of MIS. For the trainees, MIS offer long-lasting 5M working knowledge to enhance employability and for future career advancement. It encourages technical detailed study to develop analytical and troubleshooting skills. It is also used to train workers become multi-skilled and multidisciplinary technical employees. For the employers, MIS address manufacturing issues that concern manufacturers. It prepares high-performance technologies for manufacturing improvement and introduces science and engineering procedures to assisting manufacturing practices for sustainable growth. MIS is a higher TVET learning module. For education institutes, MIS provides missing link study in various engineering subjects to complement existing formal education syllabus. It can help to produce confident and marketable graduates. Education institute can adopt MIS in their learning system to strengthen industry-academic collaboration. As for the nation, MIS trains knowledgeable workforce to support country's vision of becoming an industrialized and technological society. It can promote higher TVET learning to produce more STEM-based citizens. MIS is believed to be a truly people project that benefits many stakeholders. Here are some pictures to show you some of the learning activities during the presentation of MIS programs for students and working adults from education and manufacturing industry. In the nutshell, MIS provides useful and applicable technical soft skills based on 5M concept learning. This is very much sought after industry skill to improve manufacturing process. It is a patented program developed by a hands-on industry practitioner with more than 30 years working and teaching experience. The program has received official endorsement from a few professional bodies and certainly add value to its learning. MIS can be presented through online and offline learning methods. Using Cisco WebEx or Microsoft Teams, we can conduct a real-time online training or a self-paced e-learning via digital platform. We can also run MIS courses with a face-to-face lecture-led classroom training. We hope the government, industry, and education institute to adopt MIS program to promote technical soft skill learning for existing and future technical employees. We need just one more link to make the whole learning structure become stable. We are now at the final slide. For more information about MIS topics, please browse our website or drop me an email. Thank you very much for your listening, and I hope you have enjoyed my presentation.